This lesson will look at factorising quadratics and take examples from 1.02 in the textbook on page 8, binomial factorisation. So the textbook reads, a binomial product has two binomial expressions multiplied together. So what does that mean? Well, bi means two, much like a bicycle has two wheels, and nomial essentially being numbers, so a two-number expression, or a two-number product for a binomial product. So let's have a look at what that means. Down here I've got x plus 2 multiplied by x plus 3. So these are multiplied together. So that is the product part of the binomial product, being that we're multiplying them. And there are two binomial expressions. So the first binomial expression is x plus 2, and the second binomial expression is x plus 3. So in each of these expressions there are two things. So that's where your two-number expression comes from, or binomial expression. The book then goes on to say, when they're expanded, they produce an expression with three terms, such as x squared plus 2x minus 3. This is called a quadratic or trinomial expression. And factorising a trinomial usually gives a binomial product. A monic quadratic is one where the coefficient of x squared is 1. So let's expand our binomial product out here. So if we multiply x by x, we get, so that equals x squared, and then multiply x by 3 plus 3x, and 2 by x plus 2x, and 2 by 3 plus 6, and we've got like terms here, so we'll collect the like terms. X squared plus 5x plus 6. Now going back to what the book was saying, so a monic quadratic is one where the coefficient of x squared is 1. In this case we have 1x squared here, so the coefficient of x squared in this case is 1. So this is a monic quadratic. The book then goes on to say that when the coefficient of x squared is 1, we can factorise the quadratic using a special property. This property is that the coefficient of x is the sum of the numbers in the brackets, and the constant is given by the product of these two numbers. So you will have seen this before. The coefficient of the x term is the sum of the two numbers in the brackets, so in this case 5 is the sum of 2 and 3, and the constant is given by the product of these numbers, so 6 is 2 multiplied by 3. And so basically, and that's what this rule, this monic quadratic factorization rule, goes on to say here, is that when you have your quadratic with the coefficient 1, so 1x squared plus a plus b times x plus a times b is equal to x plus a, x plus b. And if we look at that in our example, we can see that in our example, so we've got x plus a, x plus b here, that is equivalent of our x plus 2, x plus 3 here. And so once you multiply that out, our 5 that we have for our x term is actually the 2 and the 3 added, like here where we've got the a and the b added, and our 6 for our constant is the 2 and the 3 multiplied, like we've got here for the a and the b multiplied. So we can actually rewrite this. It's x squared plus 2 plus 3x plus 6. So what does this mean for us when we're factorising quadratics? Well, we'll have a look. So the example here where I've expanded it out is essentially example 4 from the textbook, page 8, example 4a. So we won't worry about doing that one again. But let's do example 4b, which is we need to factorise m squared minus 4m minus 21. So what it means for us is that we need to find two numbers that add together to give us this and multiply together to give us this. So two numbers that multiply to give us that and add to give us that. And this is what it says in the book, where it talks about the coefficient of the x is the sum of the numbers in the brackets, and the constant is given by the product of these two numbers, sum being adding, product being multiplying. So let's look at this. Two numbers that add together to give us negative 4. Well, it could be negative 2 and negative 2, but if you multiply those together, you get positive 4. So there's a hint there in that we have a negative just here and a negative just here. Any two negatives that we multiply together will give us a positive number. So that actually means we need to pick a positive and negative that end up giving us negative 4. Now, the best way to go about doing this is actually starting with our product. Oops, didn't mean to erase that. Is actually starting with our product and thinking of factors, and then working out if they add together to give us the coefficient of the m term, rather than doing what I just did. Don't start guessing numbers that you add together, because that'll take you forever. But if we think of factors that multiply together to give us negative 21, well, we've got negative 3 and positive 7. And if you look at those, the difference between those is actually 4. Well, the difference between 3 and 7 is 4. But is there a way that we can work with their signs to get negative 4? Well, negative 3 plus 7 gives us positive 4. But if we switch them around and make it positive 3 and negative 7, well, that actually gives us negative 4. Positive 3 times negative 7, 3 times negative 7, gives us negative 21, and positive 3 minus 7 gives us negative 4. So there we have it. We've solved that one. We have m plus 3 and m minus 7. Okay, we'll look at example C now. Example 4c. So y squared minus 8y plus 16. So in this case we have a negative here and a positive here. So that means we're going to have two negative numbers, because the two negative numbers will multiply together to give us a positive, and two negative numbers will add together to give us a negative 8. So what's two things that we can multiply together to give us 16? Well, we could do 2 and 8, but that wouldn't end up giving us a negative 8. We could do negative 4 and negative 4. Multiply them together, you get 16. Add them together, you get negative 8. So we have x minus 4, so that's equal to x minus 4, x minus 4, where it actually turns out that this is a perfect square, which you can read about a bit more in the book if you like, but that is x minus 4 squared. Now it's always useful to remember, on a side note, that when you come across something like this, you can actually rewrite it like this, and that might be useful in future questions. But always remember that when something is written with a square and it's in brackets, everything in the brackets is squared. Okay, finally we'll look at example 4d, which is x squared minus 36. Now, this is actually x squared plus 0x minus 36. So, this is a special case called the difference of two squares. And let's look at expanding this now first. So say we have a plus b multiplied by a minus b. And this is in the book a little bit too. You can multiply these out. A times a times negative b times a, b times negative b. So a times a is a squared, a times negative b is negative ab, b times a is positive ab, and b times negative b is negative b squared. Now we have negative ab plus ab, so they cancel, and we get a squared minus b squared. So there is the rule that something that is a squared minus b squared is equal to a plus b multiplied by a minus b. Now if you look at this, rather than going into this method and then trying to find something that adds together to give 0 and multiplies together to give 36, let's look at what we started with, get rid of all this. And so we start with x squared minus 36. So whenever you come across something that is just a squared term and just a constant with no x value term, just think it might be the difference of two squares. So if this number here at the end, the constant, is a perfect, like a square, a perfect square, then it probably is the difference of two squares. So what's 36, the square root of 36? Well, it's 6. So that's going to mean we have x plus 6 and x minus 6. And you can multiply that out to check that it works. But always, when you only have two terms, the x squared term and the constant, look out for a square here, because the difference of two squares pops up all the time.